Assalamualaikum warahmatullahi wabarakatuh and good day everyone. So I am Dr. Siti Norafida binti Jusof and we in Civil Engineering Laboratory 2 and I will brief you today the oedometer test G1, the test for consolidation. So oedometer, so did you know the oedometer word comes from? So it is actually derived from ancient Greek word which means to swell. So in this test, we can see the soil behavior that can swell or deform or compress due to the consolidation process. So oedometer tests are performed by applying different loads to a soil sample and measure the deformation response. And this result is very important as it is used to predict how a soil in field will deform in response to a change in the effective stress, which comes from building and so on. But before I go further, did you still remember or recall what the differences between compaction and consolidation? So compaction actually you already learned in the soil mechanics class. So we know from the compaction what we do is we expel the air, and we can do that by doing the soil compaction test or CBR, California bearing test in the highway lab. Meanwhile for the consolidation, it is actually an expulsion of water. It's not only expel the air, but it continues with the dissipation of water from the soil body. And we can do the test by using the oedometer test. So the oedometer tests are designed to simulate one-dimensional deformation flow, and it has a laterally confined. So the sample is held in a rigid confined ring in here. So it prevents lateral displacement of the soil sample but allow the vertical displacement. So it can swell or it can compress due to the effect of the applied loading later. And then it is also carried out in the saturated condition, and it has we assume has a constant permeability, and also we include the porous stone at the top and the bottom of the soil sample to provide a double drainage condition. Means water is allowed to dissipate via the porous stone at the top and also at the bottom of the soil sample. Okay, saturated soil sample is very important to be carried out because it could exhibit the phenomenon of consolidation. So the volumes of soil change gradually to give a delay response to the change in applied confining stress. So when we apply the load, so actually the soil volume is changed but slowly. So that's why we want to do it in the saturated condition. So from the oedometer test, by applying the load, we typically takes a minutes or hours to complete the oedometer test, and from the measurement we can obtain the coefficient of consolidation and also the permeability of the soil. So this is a schematic diagram of the confined ring together with the saturated condition. As we can see, the soil specimen is very small, with the diameter to height is 3:1 in the ratio, and we have a porous stone at the top and at the bottom. We put the soil in the confined ring and we apply the load, and around the lateral condition is saturated with the water. So now let's see together the procedure of the oedometer test. So first you need to prepare the sample. So before you start, you have to measure the height and also the inner diameter of the consolidation ring first. Okay, while we trim the soil, we can also take some of the excess soil to measure the initial water content. So take the excess of soil to become your initial water content. Okay, this is the correct way to take the weight of the soil with the consolidation ring. And after you get the data, you note down in your forms. So next, we need to prepare the consolidation ring, the cell pressure. So first, put the porous disc and cover with the wet filter paper. Okay, so next, take the soil sample. And again, put the wet filter paper. And place the secure collar at the top of the consolidation ring. So take the screws or the bolts. And place another porous disc. And lastly, put the loading plate at the center. Okay, for next, so we need to assemble the loading frame together with the consolidation cell. So this tool is similar to what we have in our laboratory. So make sure we level the loading frame correctly, horizontally. So this is to measure to ensure the level of the horizontal is correct. And then after that, set the dial gauge. So dial gauge is where you can read the deformation. So after that, you check again a level of arm. Make sure it's in the correct level. And level arm is attached with the free loading system. So this is where you want to put the loading. So we can start with 1 kilogram and increase double. And we also can decrease to get the coefficient of recompression. So load plate are added and also can be removed from the hanger. And in our case, we do the consolidation test for 1.5 hours, about 100 minutes. And then we have a extended procedure in here to complete the test for 8 days. But it's okay, we follow the video first. So later I will explain about our laboratory testing. Okay, I think that's all for the video. It is from the UWA Civil Environmental and Mining Engineering. So thank you for the video. Okay, for our lab, as we change the norm of our lab from the face-to-face lab to online lab, so we give you a set of data. So in table G11, in order to determine the initial moisture content, as you seen in the video just now, the excess of soil from the consolidation ring preparation, you can take the some of the wet soil and measure the weight of the container together with the wet soil, and you get some certain amount. And after 24 hours, you measure the dry soil, so you can get actually at the end of the process you can get the initial moisture content. You can get the initial moisture content. And after that, in table G12, you need to determine the initial void ratio. So what you do is you have to measure the internal diameter, you have to measure the thickness, because you want to take the volumes, and you also measure the soil sample together with the consolidation ring mass, and from there you can obtain the initial void ratio and also the degree of saturation. And in order to do that, in the process you will have to assume appropriate specific gravity. So usually we take from 2.5 to 2.8. You can take 2.7 as your GS, specific gravity, and make sure to use the correct density of water according to the units. Okay, now in table G13, you are given the consolidation data. Assuming that you are doing the consolidation test, have been performed in the video just now. We set the dial gauge at the 0 for the beginning. So at the time T0, so the dial gauge is 0, so the deformation also 0, and so on. But make sure to obtain first the moisture content, so you can get from the G12 table, G11 table. And as we do the loading, first loading is 1 kilogram, so I already convert to you in the kilonewton. And bear in mind, we dial gauge factor equal to 0.02 means every division of the dial gauge that the data given to you is representing 0.02 mm. So you need to times all the results in here times the 0.02, so you can get the deformation. So you read the dial gauge at selected time intervals at the quarter minutes, 1 minute, 2.25 minutes, and so on until 100 minutes, which is about 1 to 1.5 hours. So you get the dial gauge and you plot the data. So you need to plot a graph of initial height minus the deformation versus the square root time, and you are using the square root time method. So what you do is actually you have to define first the deformation, and you have to add another column to calculate the h minus the deformation, and you plot the data in a graph. So I already plotted here the axis for x and y. So just pick the appropriate scale and start to plot. Okay, I stop here. I will continue in the next video. See you later.